Pitch Blitz is a training program that prepares you for the pitch grid test. Therefore, before I explain the differences between the pitch grid test and the training program Pitch Blitz, let me give you an overview of the pitch grid test. The pitch grid test is a relative pitch test that evaluates your ability to discriminate relative pitch in a sensitivity grid. Don't be misled by the displayed pitch grid. While this may seem like an absolute pitch test, and you do have to click the correct tone in the grid, which is an easy task for those who possess absolute pitch, the pitch grid test is in fact a relative pitch test, since you identify a tone relative to a given pitch. The pitch grid test starts by playing a reference tone. At the same time, the position of the reference tone is also shown on the grid. With this reference tone in mind, your task is to identify a new pitch and click the appropriate pitch area in the grid. Your task is not to identify the tone by means of absolute pitch techniques, but to, through relative pitch techniques, identify the distance to the tone just heard. Before the tone to identify is played, there is a short pause, which allows you to get ready. As soon as the tone to identify starts playing, the timer starts running. Moving the mouse over the grid highlights the selected pitch area. Here, a grid sensitivity of 300 cents has been chosen, so the comprised area is 3 half steps. Therefore, the highlighted area jumps by 3 half steps. Your task is thus to identify and click on the appropriate pitch area in the grid as soon as possible. Now, let the test continue. In this demo, I will move the mouse, for you, to the pitch grid area corresponding to the tested pitch. Clicking in the highlighted area logs the selected area as your answer, stops the timer, and records the time elapsed. Since the pitch grid test is a relative pitch test, time is important. Indeed, for relative pitch training, speed is everything. The training program is therefore called Pitch Blitz. Answering questions quickly helps to make associations of recognized pitch distances to distance terms an automatic process. In this case, the program requires you to recognize tone distances and clicking the appropriate tone in the correct distance from the reference tone. The goal of the training is to automate the process of translating distance recognition to a descriptive value. In this case, the distance in half steps, and applying this value by counting from the reference tone to the destination tone. Placing value on speed helps you to make these steps an innate behavior. The test does not use interval descriptions, since interval names may change depending on the musical context. Of course, a musical context makes interval identification easier, as you can base your answer on contextual hints. However, the pitch grid test focuses exclusively on fast distance recognition, and on adding the distance to a given reference point. After logging the answer, the program provides feedback. If you've clicked the right area, the area is highlighted in green, and the correct tone, the tone tested, is played again. If you've clicked the wrong area, as in this example, then the color of the logged area changes to red, and the associated sound of the clicked area is shortly played twice. In this way, this feedback process allows you to hear your assumed answer. After that, the correct area is highlighted in green and the appropriate tone is played again. If you don't answer within 6 seconds, a timeout error occurs, signaled by the entire grid being highlighted in red. Again, the timeout feedback is followed by playing and displaying the correct answer. After the feedback, the program continues immediately with the next tone to test. The last heard tone from the feedback cycle, the correct answer, becomes the new reference tone. The location on the grid is highlighted in blue, but the tone is not played again. Using the last tone heard as the new reference emphasizes the relative character of the test. Your pitch is tested not in relation to a fixed reference tone, for example, A4, but in relation to a moving reference that becomes the basis for the next test. That is, you have to change your starting position each time. In this way, the anchor point for the next relative distance decision is always the last heard tone, the replay of the correct answer. The next tone is tested the same way as before, by starting with a small pause to get ready, before the tone to identify is played. Now, let us see what happens when we have answered 10 questions. A summary of the performance, for the tested grid sensitivity level, is displayed. All 10 tones tested for the current sensitivity level are shown on the grid again. Green means you gave the correct answer for the tested tone. Yellow means you selected a tone above the tested area, instead of the expected yellow answer area. Red means you selected a tone below the expected area. White means that for this tone, you did not answer within 6 seconds, and therefore timed out. Unfilled areas mean those tones were not tested. If you did not exceed the number of allowed errors, meaning your allowed errors count is still positive, then the test continues with a narrower grid sensitivity. Here the test would continue with a grid sensitivity of 200 cents, meaning the area comprising a correct answer gets smaller, from 300 to 200 cents. After another 10 questions, the grid sensitivity goes down to 100 cents. The pitch grid test does not stop at a sensitivity of 100 cents. Instead, it goes beyond half steps, meaning the grid resolution gets finer. Thus, the pitch distances can deviate from standard interval distances. For example, here, with a grid sensitivity of 33 cents, the distance is 3 half steps and 1/3 of a half step. Compare this to the standard distance of 1/3. If you weren't able to hear the difference between these two examples, then listen to the following one. Here, you can hear the difference between two tones that are 1/3 of a half step apart. Testing deviations from the standard intervals breaks the naming rules for simple interval names. The pitch grid test retains and displays the maximum time you needed to complete the task, identifying a pitch distance, and transforming that distance to a pitch grid position. Practicing an ability until it is an automatic process requires repetition and speed improvements. The speed improvements especially are crucial in this process. You must make an effort to get to the point where you take no time to think about the solution. If the answers come with no thinking, then the process is automated enough so that you have started thinking in the language of pitch distances. This means that, to get the best results, you have to learn to move the mouse pointer quickly to the appropriate pitch area in the grid, much like you would learn a new instrument. The mouse pointer may not be conducive to fast response times. However, in contrast to keyboard actions, the analog nature of mouse positioning allows for the signaling of deviations from fixed reference frequencies. Allowing for the selection of fractions is necessary for testing beyond pitch resolutions of a half step. In the first round, if you did not select another starting sensitivity, the test starts with a grid sensitivity of 1 octave. 1 octave equals 1,200 cents. That means the comprised area spans a whole octave, or 12 half steps. You can click anywhere in the octave to select it. As mentioned before, the test continues with ever smaller grid sensitivities. In this way, the test measures your interval precision recognition ability. It does not test your ability to recognize a specific interval, but does test your ability to accurately recognize tone distances. It does so by exposing you always to multiples of the interval distance. Already, the very first grid sensitivity level of 1,200 cents, a full octave, presents you with a distance range of up to 4 octaves. For example, the sensitivity level of 300 cents assesses your ability to recognize any distance within a precision of 300 cents. The test verifies not only that you can identify a minor third, but that you can differentiate between multiples of minor thirds. In other words, the interval can be a minor third, a tritone, a major sixth, an octave, or even a compound interval. Compound intervals span more than one octave. As the sensitivity, in sense, gets smaller, you have more possibilities when answering the questions. Thus, listening requires a sharper differentiation of tone distances. This usually leads to longer answer times. To overcome this, keep practicing. A pitch grid sensitivity of 50 cents goes beyond the 100 cents that separate notes in the equal tempered system. A half step equals 100 cents. Thus, if you omit the unison, you have 12 distance possibilities to select in an octave. 50 cents correspond to a quarter step or half the distance of a half step. That means that the tested tone may not fall on a predefined note in the equal tempered system, thus doubling the choice of distances. For example, the tone played here is between the note D and F. In the test, you must therefore recognize when a heard distance is off of the standard interval distances, and thus leads to a tone between the official notes. Since the last heard tone becomes the new reference tone, you must be flexible enough to work with tones that deviate from the standard equal tempered system. For example, a distance of a minor third will lead to an in-between tone again. Here, to the tone between G4 and G#4. That means, if you hear a minor third, then you must keep in mind that the starting tone was 50 cents off of the equal tempered system. During the test, you are allowed to make one error. If the allowed errors count falls below 0, the test stops, and your pitch ability is calculated from the last grid sensitivity you passed, the number of octaves selected, the remaining allowed errors, and the maximum time you needed to answer a question. If the allowed errors count is positive and you have answered 10 questions, then the grid sensitivity statistic is displayed, and the test continues automatically thereafter with the next sensitivity level. The test starts with a grid sensitivity of 1,200 cents, meaning you have to answer 120 questions. You can shorten the test by selecting another starting grid sensitivity. Each sensitivity level skipped reduces the number of questions by 10. In going beyond the precision of half steps, the pitch grid test is a listening test that quantifies your distance hearing ability beyond the usual relative interval hearing accuracy. Since you do not need any musical education, this test has the advantage of being usable by non-musicians as well. Of course, if you are not used to listening for pitch, you will probably reach a pitch grid sensitivity of only one octave. To make progress, you need appropriate feedback and training. A low score in the beginning should not discourage you. Even for musicians, the pitch grid test is challenging. Many musicians will be disappointed when they do the test for the first time and see a low grid sensitivity. They base their own assessment of relative pitch sense on simple interval recognition. And of course, they identify simple intervals with their instruments that produce a lot of familiar overtones quite easily. Or, they base their own pitch sense evaluation on complex real situations within a musical context from which they obtain related information. The pitch grid test evaluates a general pitch distance hearing ability and does not focus on specific simple interval recognition. For example, recognizing a perfect fifth, or recognizing a major third, but rather determines your ability to differentiate sound distances within a given accuracy. This is your relative pitch sensitivity. For example, a grid sensitivity of 200 cents accepts answers covering a range from -100 to +100 cents of the actual distance still is correct. For a grid sensitivity of 100 cents, your answers must be in the range from -50 to +50 cents of the correct distance. And for a grid sensitivity of 33 cents, you must discriminate pitches with a precision of 16 cents. Therefore, the pitch grid test is much more ambitious than the usual interval tests. This is also because the test covers multiple intervals from the beginning, including compound intervals. On the other hand, the pitch grid test is simple, in that it works out your pitch distance accuracy score, and lets you easily see where your relative discrimination abilities are. With your training techniques, you can improve your interval listening skills. The pitch grid test allows you to assess your progress on interval skills and your interval accuracy abilities. Its simple environment and easy reproducibility make the pitch grid test a scientific means of determining relative pitch hearing. The pure sinus sounds used during the tests eliminate side effects. The sinus waves also help to keep the focus on the main criteria for relative pitch, the frequency ratio of two sounds. The first notable point you realize with this test is that you need good equipment for ear training. Low pure sinus waves are not audible on laptops, as built-in laptop speakers are not meant for reproducing low bass sounds. Now, let me show the differences between the training program Pitch Blitz and the Pitch Grid test. First, Pitch Blitz is not a test. Instead of evaluating your score after the second error, Pitch Blitz allows you to make 8 errors. This invites you to keep trying, as a minor error does not block you from reaching the next level. Second, and more important, with Pitch Blitz, you can activate a mode called Distance Test. When activated, Distance Test forces you to answer pitch questions in a relative manner. With the Pitch Grid test, it is up to you how to solve each question. Unfortunately, many people are tempted to answer the question according to absolute pitch. For example, if the tone tested is an F5, people try to find the tone they hear directly on the grid, instead of using distance detection and determining the end tone via applying the distance to the reference tone. People think they can simply click the tone they heard. Yes, doing so is easy if you possess absolute pitch. However, you should first concentrate on listening for relative pitch distances and advance this skill to blitz speed. You should then determine the position of the tone in the notation space. With distance test activated, you are forced to give the answer as a pitch distance. That means you can click only in the distance bar. You cannot click on tones in the grid. The distance bar covers only 2 octaves, one octave going up from the reference tone, and the second octave going down. Therefore, if the tested distance is larger than an octave, as in this example, you must ignore octaves. Thus, you must select a distance that ignores octaves, instead clicking a distance that has a corresponding area within the range of an octave. This is also good training to understand the concept of an octave. In many cases, you can ignore octave skips. Octave changes have less influence on musical perception than non-octave changes. The distance test option also eases the task of giving a correct answer, because you only have to identify the distance. Whereas in the regular test, you have to apply the recognized distance, including octave skips, and must calculate the resulting end tone by adding the distance to the reference tone, before you can click the location of the tone on the grid. Selecting the Do Distance Test option also allows to simultaneously highlight at the same time the corresponding grid area that you would have to click in the test. With this option, the end position of the selected sound is automatically calculated for you and made visible on the grid. Note that here, with a grid sensitivity of 33 cents, the distance bar also contains more selectable distance points. Clicking in the bar logs the selected distance and appropriate grid area as your answer. Then the feedback cycle starts as described before. Third, Pitch Blitz lets you improve your speed in identifying pitch grid distances. Actually, this is the simplest exercise. You don't even have to listen for the tones. This is thus the best exercise to try when getting started in familiarizing yourself with the pitch grid. The exercise is simple, because when the tone, for which you have to find the distance, plays, the answer is already highlighted. This reduces your task to counting the half steps in possible fractions, from the reference tone to the played tone, and then clicking the appropriate distance in the distance bar. The time you take to do this task will be recorded and scored. Thus, you will improve your grid distance reading speed. With this training, you will also support the reverse task of adding a given distance to a given grid point. In the pitch grid test, This reversibility will help you to be faster and score better. If you also select Show Grid Position, then answering gets even simpler. You can just slide the answering handle until the grid position matches the result shown. If you have no music education, this could be your entry point to the realm of relative pitch. Of course, Pitch Blitz supports training of the reversibility, adding a given distance to a reference in a beeline. If you click this option, the distance to add to the reference tone is shown on the distance bar. As a hint that you're doing the add distance exercise, the color of the frame is red. Your task is to add the given distance to the reference tone, and click the appropriate tone in the grid as soon as possible. If the distance exceeds an octave, as in this example, the number of octaves is also marked in the distance bar. In this way, you can solve the problem by counting to the correct answer on the grid without listening to the tones. Ignoring tones in the beginning may help to bring you up to speed in the notation space, but ultimately, the pitch grid test is a relative listening test. Fourth, the pitch grid test lets you decide whether to do the easy test or the full test. The full test will present you all tones in the 4 octaves, while the easy test will present you with only the tones from the upper 3 octaves. The easy test option was introduced due to the fact that most laptops are not capable of reproducing low tones. This is especially true for pure sinus waves. Since pure sinus waves don't have any overtones, you hear nothing if the loudspeaker cannot reproduce low frequencies. Again, this fact underscores why you should use quality equipment for ear training. Because relative pitch training is frequency ratio hearing, the use of pure sinus waves facilitates the focus on this task. With normal tones, you will probably use overtones that characterize an instrument as hints to identify the destination tone. Even with sinus waves, you can use these hints, since the loudspeaker housing will remodel the sound waves through its own resonance body, and thus adds overtones. Thus, if a pitch is near to the resonant frequency of the housing, it will result in a louder sound. In this way, you may be tempted to use loudness as a wrong hint when solving the pitch questions through absolute pitch techniques. However, you should use relative pitch techniques to find the result and let go of absolute pitch detection patterns. The effect of sound wave remodeling is especially annoying when loose device parts start to clatter with a specific frequency. Most likely, you'll use this clatter to identify the pitch easily by absolute sound identification. Unfortunately, because the resonant frequency will be on a different frequency in other environments, you should try to ignore clattering sounds during pitch identification. Instead of offering only the easy test option, Pitch Blitz lets you select individual octaves for a narrowed training environment. Taking away octaves reduces the selection possibilities drastically. For example, the pitch grid test with a sensitivity of 300 cents offers you 17 clickable answer locations, whereas if you select only one octave, the possible clickable areas are reduced to only 5. Since Pitch Blitz tests many combinations of multiples of minor thirds, and tests various starting locations and directions up and down, it gets a lot easier for you to make progress if only one octave is selected. Once you have a good grasp of locating the right tone within one octave, try another octave. Then extend your range by combining the 2 octaves. Here, the similarities of sounds that are an octave apart help you learn this very important aspect of the function of the octave: adding and subtracting imaginary octaves. Understanding the division of the sound space through the concept of the octave sharpens the ability to classify distances. Most professional musicians will feel at home when selecting just one octave. However, even with only one octave selected, the pitch grid test is challenging when the grid sensitivity drops below 100 cents. Thus, the pitch grid test gives you a new tool to improve your relative pitch listening. Fifth, the Pitch Blitz program lets you select an equal tempered setting. With this option set, The exercises start by playing a reference tone that corresponds to the nearest equal tempered note of the last tone heard. This is especially useful if the destination tone of the last exercise did not fall on an equal tempered note. However, keep in mind that, in the real world, deviations may be present, and you have to cope with these circumstances. The equal tempered setting also offers you the fixed note option. This allows you to train your relative pitch sense from a fixed reference point. For example, if you set the fixed reference note to C4, then you always have to determine the distance relative to C4. Sixth and lastly, since Pitch Blitz is not a test, the program not only evaluates your sense of relative pitch, but also contains a timeline, so you can better observe your progress. The timeline displays the pitch grid test scores for the last 100 training days. Since the scores take into account not only the number of errors, but also how many octaves you have selected, and the maximum time used, the statistics show even slight progress. Hopefully, your line will go up, without too many backslides. If you want to see details of a day, select the day, and click Show. This will show you the best past sensitivity level for that day, including max time, number of octaves selected, and errors made. Using a grid layout supports the association of the heard sound in relation to the grid location. The grid locations correspond to piano keys that are tuned to the equal tempered frequencies. When listening to music, we hear these frequencies most often. Therefore, the associated grid frequencies can be used as a bridge to enforce standard tuning. However, the main goal of Pitch Blitz is to allow you to better hear relative pitch deviations from standard pitch distances. Today, there is a trend toward flexible and experimental music. That means you hear more slides and bends. Therefore, it is important to recognize deviations from standard notes or intervals. Pitch Blitz is a good way to train this ability, and thus helps you to improve your listening skills. You learn to describe pitch distances in half steps and fractions of half steps. You also learn to work with pitches that start with a deviation from the standard equal tempered tuning. Take the challenge and try to outperform your own best mark by answering the questions even faster. See your score growing, and gain confidence in your ability to reliably estimate pitch distances with precision. Thank you for trying my approach to improve your relative pitch hearing.